Alright, tomorrow we'll be starting work on exponential functions. You should be familiar with them from algebra. Here's an exponential function of x equals a times b to the x, where a is like your initial amount. You've got a sum of money, or you've got a bunch of bacteria or something, times a rate, and you to the x power, which means times b times b times b times b. So your initial amount, guess what? It can't be 0. You can't have 0. Okay, it's got to be something. All right, that's the only stipulation for initial amount. B has to be positive. Okay, and it can't be obviously 0. Also, I forgot what else. B cannot be 1. Boy, I can't believe I missed that. Okay, so A can't be 0. Obviously B can't be 0. B can't be 1 either, but B has to be positive. So basically B is greater than 0. All right, and we've got a little, but if B is less than 1, that's still positive, and that's a fraction, and we'll talk more. That'll be more of a decay situation. Okay, all right. So initial amount can't be 0. Obviously, your growth or decay rate, your rate of growth or rate of decay, can't be 1, because anything times 1 times 1 times 1, nothing changes. Can't be 0, obviously. But your B is positive, okay? And you're going to break it down to B is greater than 1, where you have a graph like so, and we'll get more into that. B is greater than 0, but less than 1, you're going to have a decay rate, okay? So, anyway, we'll talk more about that in the next couple slides, okay? If something grows by a percent, example, I've got 7% growth on my money every year. I need a growth rate. So I take this percent, and here's how I get a growth rate, 1 plus r. And your rate, you need to convert this into decimal form. So remember, 7% is going to be 0.07. So I take 1.07, this right here guarantees 100% of the original amount plus 7 more percent, okay? So I want a rate right here. I take 1 plus the percent growth and convert it to decimal. So 7% growth, 1 plus 0.07 equals 1.07. 1 plus your rate in decimal form. Okay? So if I've got $10,000 that grows at 7% every year, I can have my initial amount A would be $10,000 times my growth rate B. Okay, and this could be X and X, or I could use T for time. Okay, all right. Okay. Big thing is 1 plus R is your growth rate, and R is in decimal form. Add it up. Okay. There's going to be questions about doubling your money, tripling your money. And the big thing is, it doesn't matter. What you're going to come find out is, it's not going to matter as far as how long it takes to double your money. It has nothing to do with how much money you have. It has to do with your interest rate. Okay? And some of you have talked about the rule of 70s. Divide an interest rate into 70, and it gives you how many years it takes to double your money. All right, so let's take a look at this. Let's say I started off with $100, and obviously if I wanted what's twice 100? If I want is 200. Okay, so notice I've got 100 times. Here's a 7% growth rate at 7%. Okay, this is at 7%, like we've been talking about. All right, so 1 plus 0.07, like we did in that 1 plus our rate, is 1.07 to some time value. Okay. So notice I want to solve for how long it takes to double my money. Well, notice if I divide both sides by 100, I'm left with 2. Okay, and 2 equals 1.07 to some exponent t. All right, now remember, one of the rules of logarithms is if I take the log of something with an exponent, the exponent moves down in front like a coefficient. So if I take the log of 2 equals the log of 1.07 times t, notice that t comes down, and notice I'll divide by this, log of 2 divided by this, and I solve for t. Notice I divided both sides by log of 1.07, okay? The important thing is, this amount doesn't matter. What matters is the rate. We're dividing by the rate here, the log of the rate, okay? Here's another example to hit home, okay? All right. This time our amount's $2,000. Guess what? And the rate's 4%, 1.04. Okay, I want to see how long it takes to double my money. Well, that's why I plug in 4,000. What's twice of 2,000? What's double 2,000? 4,000. So I'm solving for t. So notice I divided both sides by 2,000. What do I get over here? 2. Does it matter what my amount is? I don't care if you double your money. If it's 10,000 to 20,000, when you divide everything out, you're going to get 2. Okay, so again, I'll get 2 equals 1.04. I'll take the log of both sides to get this down. I'll do one more problem I've got worked out. So again, so really, if I'm worried about doubling my money, I don't even have to put in the initial amount. I can just put A, and what's A become when I double the initial amount? It comes 2A, all right? And so these A's cancel out, and there's your 2. So if you ever want to see how long it takes to double your money, just take 2 equals your growth rate to a certain time period, t, which is your exponent. So watch us solve for this. How do I solve for an exponent? We need to take the log. In this case, I'm using natural log, ln. Take the natural log of 2 and the natural log of the right side. What happens? This allows the exponent to come down in the front as a coefficient. And then all I have to do now is divide by this. The log of 2 divided by log of whatever my base is, whatever my growth rate is, okay? Whatever my rate is. Might be a decay rate and down in the future, but divide by that, and I solve for t, okay? Guess what? If I wanted to triple your money, same principle. It's just going to be 3. Hey, I want my amount to be 3 times the amount. This cancels out. Guess what? 3 equals this. I'll take the log of both sides. So that means log of 3 equals t, log of whatever my rate is. I divide both sides by log of b, and that will be, that cancels out, and t equals a certain time. So if you wanted a quadruple, it would be 4. Be 4 equals 3 for triple. Okay, so hopefully you get the picture there, okay? And finally, here's our graphs for exponential growth or decay, all right? So if my b, remember b has to be greater than 0, it's got to be positive, and b can't be 0 or 1. But if b is greater than 1, it's a growth rate. If b is positive still, like it's our requirement, it's got to be positive, make that up, okay? Then b is positive, but it's less than 1. That means it's a fraction, like we've been doing with these geometric sequences, times 1/2, times 1/2. Notice how my value keeps shrinking because I'm multiplying by less than 1. So that's what your graph will look like if it's a decay. Okay? Got one more slide. Notice decay rates. This is something we'll get into later. This is where your rate is less than 1, but still greater than 0. Like my money is, I'm losing money in an investment. My money, the value of my money drops or decreases 6% every year. Okay, or maybe I'm pulling 6% out every year to spend on vacations. Okay, so my decay rate be 1 minus r, and that's this rate. It's this rate in decimal form, so that would be 0.06. Remember, 6% is 6 out of 100. That's not a very good 6. 6 out of 100, which is 0.06. So 1 minus 0.06 is 0.94. Okay, that's my decay rate. So I'll take my initial, let's say I have $10,000 times, this is my A, times my B, to the x power. It could be, we could use x or maybe t if it represents time. Okay, every year times 0.94, 0.94. And notice your money is going to shrink because you're multiplied by something less than 1. All right, so there's good information to get you ready. Remember, anything to the 0 power equals 1. Okay, all right, so that's just another tidbit. All right, that's all I have, guys. Hopefully you watch this. Okay, have a good night.